Okay, here we go. We're talking about vertical and horizontal asymptotes, and these will be a good stretch for you. This class kind of has a lot of that. You learn a little new, something new every day. But we really need to still know domain. Man, I've been pounding on that for a long time. I hope you can do this one. Try it, all by yourself. Tell me, all real numbers except what doesn't work. Don't say it. Write it on your paper. You may need to make a little number line. Okay, here's what I would have done. Set it greater than or equal to 0. Why could it be 0? Because the square root of 0 is a number. It works. So I can factor it to this. And then I get x equals -4 and x equals 4. Those seem like important points to me. Put them on a number line. -4. 4. Do those points themselves work? Well, try them if you're not sure. Go stick it in. 4. Does that cause a problem? Some people think so because they go, oh, 0, it can't be 0. You can have a square root of 0. It's okay. It works. And so does that work. And then I test in between them, like sticking a 0 into the function. If I put in a 0 right here, does that cause a problem? Square root of a negative, is that a problem? Yeah, you can't have square root of negatives, so that does not work. And then you test out here, like with a 5, and you get a positive under the square root. Here it works too. Again, what I mean by working is any number that isn't negative. As long as this square root comes out positive, I'm happy. All right, so these are the places that work. So you can say -infinity to -4, bracket, union with bracket 4 to infinity. Any questions about domain? Okay, then next one. Let's review odd and even functions. Just learned those yesterday. There's 2 rules. I asked you to memorize them. Try to remember. The odd rule has f of x's in it and has an equals in it. Try to write it down. Write down the rule for odd, and then write down the rule for even. In case you forgot, you both start with f of -x. And the one that's odd has got another negative in it. That's odd. And this one has a regular f of x. Now, which of these looks like it would be easier to do? The odd rule or the even rule? Even, because it's got less junk to do. The right side, I don't even have to do anything. So I'd want to test even first, because if it comes out even, then I'd be done. And isn't there like a, well, there's at least a decent chance that it'll come out even, and then I can be done with the problem right away. So try the easy one first. Everybody try that right now. See if you remember how to set up the little proof thingy and see whether this one is really even or not. So what did you do? All right, so I'm going to put a square root here. And then empty spot for the x squared minus 16. And you said put in a -x there. And then I square that and I get x squared minus 16. And then I go to the f of x, and that is already given to me. And are these equal to each other? Yes, they are. So what's the answer? It's even. Raise your hand if you get that. Okay, good. What if we tested it and it hadn't worked? What would we test next? And what if it was not either? Then it's neither. Not even, and then it's not odd, then it's a neither. All right, next thing. This is the rational function. It is a parent function that you need to memorize if you haven't already. And this function has a graph that looks like I have on the board here. It's 1 over x. And the important points on the graph are these dots that are kind of like made a little bit bigger than the others. It's at 1, 1, and -1, -1. And then they just get closer and closer to the asymptotes and never touch. Okay, so if I was going to ask you for the domain of this thing, it's pretty simple. What would mess it up? Everything works except what? You can't have x be 0. You're right. Now, I could write this -infinity to 0 and then 0 to infinity, but there's a faster way, and I'm going to let you do that on this type of problem for 2 reasons. But one, it's faster. Here's how you write all real numbers. See how fast that was to write? It's a double straight up and down line and an R. All real numbers where x cannot be 0. That's a great way to write that domain. It's faster. And the reason I really like it is because it also contains within it the vertical asymptote. Because if x can't be 0, the asymptote is at that spot. It's at x equals 0 that the asymptote is. So this is the line x equals 0, and it runs just like this, right here. That's our asymptote line we're talking about, that it can never touch. And notice how it was in the domain. So whatever the domain is, that's telling you vertical asymptotes. Okay, next thing. The horizontal asymptotes are lines that are like this on the horizon, right? And they're lines you can never touch, and you can see the answers that it's y equals 0. But I'm going to show you how to find those when you don't have the picture to look at. All right. Here is one where there's no picture. Do you know what that graph looks like? I don't know what that graph looks like. So I bet you don't know what that graph looks like. So I would recommend that you write this one down. This is a classic, like, contains everything you need to know for today. It's kind of the main thing I'm trying to teach you. How to find domains of these verticals, horizontals, and it's got this list of rules, bigger on bottom, bigger on top, same on both. And this is the kind of thing where, you know, not all notes are created equal. When you take notes on some things, they're really important, and there's other things that aren't really important. And I asked a person I knew one time who had had a straight A average, 4.0, when there were no weights on grades. Okay, so this person had never gotten a grade that was ever less than a straight A at any course they ever took. Okay, and I know there might be a few of you in this class that have actually pulled that off, which is awesome. But I asked her, and she made it all the way through high school and college and never got anything less than an A. And I asked, what was your secret? And she shared one thing. She said it was that she took really good notes, and every day after classes was over and she went home, let's say that you had 5 classes where you actually took notes or, you know, learned something that day. You know, one of your classes you were out doing some service project or whatever, but let's say there were 5 classes a day that you learned something new. She would go over her notes for 5 minutes for each class, and she would review what the teacher had tried to teach that day. What were the main points the teacher was trying to get across? That was her secret. Beyond just normal good habits of studying for tests and all that kind of stuff, it was the notes. So anyway, I hope that you take good notes in here, and you'll like yourself later, because on the test day, you can flip through them, and anything that's got a big star next to it or something means, oh, Server said this was really important, which, why would I say that? Because it's probably going to come up on tests and stuff, right? So, be smart about how you take your notes. All right, back to this. Here's how you do these. The domain, if you don't know how to do it by now, I may have to get out a wet noodle. Start the beatings. All right, so I look at the domain as the denominator or square root. There is no square root, so I'm looking at the denominator, and what would mess it up? What? -2. So everything works except x cannot be -2. That's a new way of writing it, and I do want you to do it that way today. Okay, next. The vertical asymptotes. It's really easy to get the verticals and the horizontals confused. The verticals are the x things, and here's a visual way for you to remember this. Watch my V. Can a V turn into an x pretty easily? Yes, it can. See? These vertical asymptotes. And x equals, and those come right from the domain, -2. Because if it was something that messed up the domain, doesn't it make sense that that would be an asymptote? All right. Now, the horizontals, I have a little sneaky way of making you remember that, is a y equals thing, see? The horizontal asymptotes. The y equals things are given by these. These are rules. I know you learned them in higher algebra last year, but some of you were in other places like, I don't know, China, or you weren't paying attention in higher algebra, and you don't know Bigger on bottom, bigger on top, and same on both. How many of you this rings a bell? You kind of remember it a little bit from last year. Okay, good. Then, here's the rules. If it's bigger on bottom, what do I mean by bigger? Bigger means the degree of it. This has a degree of 2. This one doesn't have a number here, so I'm going to say it has a degree of 1. So this is bigger on top. It's just all about the degree. So this guy is bigger on top, so he's a bot. You're either bigger on top, or you're bigger on the bottom, or you're same on both. You got to be one of those. And if they're ever bigger on the bottom, then the asymptote is y equals 0. If they're ever bigger on the top, then they're a bot, and there's no bots, which means there's no asymptotes. Is that normal? Yes. In fact, most graphs don't have any asymptotes on them. Most graphs are bigger on top. Most graphs are of things like this. And the bottom is just like a 1, so they're bigger on top. Most graphs are bots. All right. And the last one is the SOB. Okay, you've probably heard that saying before. They're the ones that are hard to figure out, coincidentally. So they're kind of an SOB ratio. Y equals a ratio, and it's the ratio of the lead coefficients. I will explain that more in just a second. So if they're bigger on the bottom, it's y equals 0. If they're bigger on top, it's no. There is no bots. There is no horizontal asymptotes. And the last one, y will be a ratio. So your horizontal asymptote, it'll have one, and it'll be a ratio of the lead coefficients. All right, so in this case, it was bigger on the top. So it's a bot. So y equals, you just say none. There's no horizontal asymptotes. Okay, let's look at another one. Wait a minute, is that the same one? Okay, I think it skipped one. We already talked about the parent one. Let's do this one. Okay. Start with the domain. Again, you should be able to handle that by now. Except now write it in this way. All real numbers except x cannot be whatever. Okay, write me the domain for this thing. Then use that to tell you the verticals. And then use bigger on bottom, bigger on top, same on both to figure out your horizontals. I'll give you 30 seconds to comply. Okay, I'm back. Here we go. The verticals are x equals things, just reminding you. So x equals, and they come from these. Uh-oh, I better get those first then. So the domain was where x cannot be -2, otherwise it would crash the function, right? And x cannot be -7 also. So what are my verticals? X equals 2 and x equals -7. The horizontals, those are the y things, remember? The y things are y equals, and then I got to decide. Bigger on bottom, bigger on top, same on both. And a lot of people screw up and think this is the same on both. It's not. Because if you multiplied this out, do you get you'd have an x squared on the bottom? So it's really bigger on the bottom, isn't it? So if it's bigger on the bottom, what is it? Wait, if it's bigger on the bottom, it is what? Y equals 0. Because that's a Bob, and Bob is y equals 0. If it had been bigger on top, you'd have said none. There were no asymptotes. And if it was the same on both, you'd do a ratio of the lead coefficient, which would be a 1, and a 1 down here. But it's not. So, yes. Oh, I think that's just a mistake. This is supposed to be a -2. I'm sorry. This is just supposed to be recopied down here. So thank you for catching that. All right, let's move on. So if I give you a few, you should be able to tell me fairly quickly if it's bigger on top, bigger on bottom, or same on both. What's that? Bigger on top. So what's the rule for bots? There's no bots. No asymptotes then. How about now? Bigger on bottom. What's the answer? Y equals 0. There's a lot of those too. What there's not too many of is that kind, where it's same on both. And if it is same on both, it's a ratio of the lead coefficients. 3 over what? 1. So this would be y equals 3. 3 over 1 is 3. Okay? So what that means is if I graph this thing, there better be a line at y equals 3 Is this a spot where y equals 3? Yep, that's a spot where y equals 3 and probably all the way across there. And there must be a spot there where this graph can never touch. So if this graph's going along, it must be like, whoa, I'll get closer and never touch it. All right? Okay. Let's move on. This one. The domain. What are the things that would mess up my domain? All real numbers would work except what? What's this one mean? What would mess that up if x was what? 0. That's the same exact thing as if I had said this. X can't be 0. So all real numbers, x cannot be 0. X cannot be also what? 3. And then the verticals, they come from these. So I say x equals 0 and x equals 3. The horizontals, they come from the rule. Bigger on bottom, bigger on top. Same on both. What is this? Same on both. So it's a ratio. So what is it? 5. So it's y equals 5. You get that? Raise your hand if you would have got that right. Okay, good. It gets harder. Rational functions are fractions. You know, they're like something on top, something on the bottom, right? In any fraction, if you have a number like this, these 2's here, you can cancel them off like I did here. And when you cancel them, remember they get replaced by 1's. They don't just disappear. And then all of a sudden this has been reduced from 2 over 4 to 1 over 2, and that's okay. Well, the same thing happens in algebra. I can cancel this. Remember, when I cancel it, they don't just disappear. What do they turn into? 1, so then it's y equals 1. So it seems like the graph should just be y equals 1, which is a line that runs along like this. Yeah, so, my next slide, there it is. There's my answer, right? Wrong. Only because of one little thing. What one number would screw this all up? -3, because if I stick in a -3, I have a 0 on the bottom. Even though there's a 0 on the top, it's not okay to have a 0 on the bottom. So something special has to happen where x is -3 because this function gets messed up. So how do we sort of say that right there's a problem? Well, we have a holy function. We have a function with a hole in it. Okay, so right at that spot, because -3 would cause a 0 on the bottom, we have to have a hole there. Notice I say a hole instead of a hole. Okay, moving on. This one, if I'm going to try to get those top and bottom to cancel off, it's going to create what? It creates a hole. At what? -3. But what does the rest of the graph look like? You have to go back in and replace this with 1's, and you'll have y equals 1 over x. And I know what that graph looks like. I showed you at the beginning of the hour. It's this one. It goes through these 2 key points, and then it goes like this. You should memorize that graph. You're going to see it again. Now, I have that graph, except, wait a minute, at one spot I'm going to have a problem. Or is there 2 spots? I'm going to have a special kind of problem here. That's called a hole. Because there was something on top and something on the bottom it canceled, that creates the hole at -3. So at -3, right here, I would put an empty spot, like a hole right there, showing that the graph has a problem at that spot. It's called a discontinuity. Then I have another problem where x is 0, but that's already on the graph if you think about it. X equals 0 is this line right here, and I already have an asymptote there. Yeah. Graph isn't going to have a problem because it never goes there. Okay. All right, so here is a typical problem for today. It's even got holes involved. If you have these canceling off, you're going to create a hole at x equals 3, right? That's where the hole is going to be. And you're going to have a graph of y equals 1 over x. Do you see that the board has a graph of y equals 1 over x? Do you see that there's a hole where x was 3 right there? You get that? All right. I'm going to pause for a second. Okay, take a look at this one. Do you see there should be a hole? Where? -3. Cut the cancels there and there. And -3 is the thing that makes it special, because that would have a 0 on the bottom. But it's being canceled by the thing on the top. So -3, there should be a hole right there, and there is. Can you see that there should be something special about negative 2? Is negative 2 going to cause a problem for this function? Yeah, because if you stick that in, you're going to get a 0 on the bottom. What does that make it? An asymptote. So this one's going to be a hole. This one's going to be an asymptote. So how can you tell them apart? The holes are the ones that have the same thing on top, and they're the things that cancel. The ones where there's just a problem on the bottom, those are an asymptote line. All right, so moving on. This one, can you have one with 2 holes? Yes, you can. This graph is totally not in the right spot. So I'm going to put it in the right spot after I figured out things like where are the asymptotes supposed to be. All right, so first thing you do in a problem like this is the domain. The domain of it is what will be okay to use. Everything except all real numbers, except you can't use what? Can't be 0. What else can't you use? X cannot be negative 3, and X cannot be negative 4. So my domain, those are 3 special spots. And wait a minute though, 2 of them are these kind. That means those 2, what kind of things? Those are holes. What is the other one then? That's an asymptote. There's an asymptote at X equals 0. So that means I can move this thing to X equals 0. Now I'm going to check where my Y ones are. Is it bigger on bottom, bigger on top, or same on both? Some people ask, does it matter if you check that before you cancel? Well, it's going to be the same thing. If it's bigger on bottom before you cancel it, it's still bigger on bottom after you cancel it. Okay? So it's bigger on bottom. What's Bob? Y equals 0. So X equals 0 and Y equals 0 are my 2 asymptotes. So I know I put my graph in the right spot then, which means it's basically the parent graph, except it's got holes at negative 3 and negative 4. So I could take this and put a hole at negative 3. And take this and put a hole there at negative 4. Okay? All right. Now, sometimes you need to factor it. Take that equation, factor the top. I betcha if you just use your head, you can know right away what one of the 2 factors is. If you just think about it. Do you get where I'm going here? The bottom has an X plus 3 on it. Doesn't it make sense? The top probably has an X plus 3 on it, because then they'll cancel. And you just have to make sure it actually works. And yes, it does if you put an X minus 4. And then this will cancel. And what it happens when you cancel something like that? It makes a hole at negative 3. All right, this guy. Don't forget that this kind can factor too. It's called the difference of squares. The X plus 2 and X minus 2. And that way, the X minus 2 will cancel. Cancel, cancel, and it made a hole there. Where is the rest of the graph? These are always Y equals things, or F of X equals. So it's Y equals X plus 2. That's the graph. Do you remember how to graph something as simple as this? Its y-intercept is what? Come on. Y-intercept is 2, and has a slope of what? 1. So it's got a y-intercept of 2 and a slope of 1. This goes like that. Does it look like it has any asymptotes on it? Does anything stop this line? No, there's nothing, no asymptotes. It doesn't have a horizontal or vertical asymptote. If I checked it that it's bigger on the bottom, bigger on top, or same on both, it would be bigger on top. What's the rule for bots? There's no asymptotes, right? And then for the, why isn't there, shouldn't there be a problem at X equals 2? Yeah, but it wouldn't be a asymptote. It would be a hole at X equals 2. So like right in here where X is 2, there'd be a hole right there. Okay, moving on. Sometimes they give you an equation of a line with a hole in it, and then you have to figure out what the equation would be. Like they'll show you this picture, and then you'll say, oh, well, it must be y equals 1. But it used to have a hole in it that got canceled off of x minus 5 and x minus 5, because that made 5 the hole. See how I wrote the equation for that line really easy? This one. I'd write the equation for the line by saying, okay, the line is y equals, and it's going through the y-intercept of 4, so it's plus 4, and it looks like it has a slope of 2, so it's 2x plus 4. I just wrote the equation for the line. Easy peasy. Now I got to recognize the fact there's a hole at -3. If there's a hole at -3, that meant that there used to be something on the top and the bottom that canceled. What would have been there? An x plus 3 and an x plus 3 would mean there was a hole at -3. Yep. So there's my equation for that line. Looks kind of complicated, doesn't it? But you could do that. All right. And let's put it all together. Sometimes you have to factor, like on this one. All right. I want you to do this problem, start to finish, see if you can tell me its domain. It's verticals, which come from the domain, and they're the x things. And the horizontals, which are the y things, which are about Bob. And if it has a hole, tell where it is. If you keep sleeping, I'm going to have to throw things at you. All right. Let's go. All right, first thing I do is factor it. Cancel that off. Yay. Domain. What are the things that would mess this up? All real numbers work except, give me some things that wouldn't work. Can't be what? -3, and it can't be what? 4. Okay, now the verticals are the things that usually come from these x's. But if one of them's a hole, it can't be a vertical asymptote and a hole. It's got to be one or the other. So if I put both of these down, it's a really common mistake for kids. And they say, but why can't I put both of them down? They're both causing a problem because one of them isn't an asymptote. What's that for? That's actually a hole, see? So this 4 can't be listed in with the asymptotes. That goes at the end here. X equals 4 is where there's a hole. And the horizontal ones, I put the little H there in red to remind you that it's a Y thing, Y equals. So it's Y equals, bigger on bottom, bigger on top, same on both. What's this? Bigger on the bottom, so what is it? 0. Raise your hand if you had those right. Okay, good. All right. If this is the same exact kind of a deal, how would you start? Factor it. Then you probably have an x plus 5 cancel is my guess. All right. I think that's enough practice problems for now. So your assignment is right here. It is page 103, 55 to 62, 67, and 72 to 76. It's not that long, but kind of medium size and it's kind of medium difficulty. All right, there you go.